Let's start with lesson 14, end of the unit questions. Let's start with the first exercise. Who is going to read that? Olivia, can you read this for us?
The chemical name of marble in calcium carbonate is in the experiment shown below equal. In the experiment shown below, equal masses of marble lumps, small marble chips, powdered marble, were placed into equal volumes of dilute hydrochloric acid. Okay. In which beaker will the reaction be fastest?
Okay, what do you think?
In C.
Okay, can you explain why you think so?
Because
so what is that we are doing? We have marble lamps, small marbles, and here we have powder.
They are smaller and they react faster with.
So the pieces here of the powder you are saying, right? So the particles of the powder react faster with the hydrochloric acid. Yes. So that's why, okay. So we are increasing what? The surface area, okay? Do not forget that. Okay, let's start with the other questions. What says, when the reaction between the calcium carbonate and dilute acid occurs, carbon dioxide gas is given off. How would you test for this gas, and what would you tell you that the test is positive? Okay. Who's going to do this? So how we can test for the presence of carbon dioxide? What we should do? What we should do? Where is Noelle? Yes, Noelle, please. So how we can test for the presence of carbon dioxide? Okay. You have to unmute yourself first. What do you think we should do? Let's say I am using a liquid soap, okay? And bubbles filled with carbon dioxide are appearing here in the surface. So what should I do to test the presence? Yes, Alexa.
We can use
yes, Livia, yes.
We can use lime water.
Mm-hmm.
And it turns cloudy from the carbon dioxide.
Okay, one. What the other? So I said I have bubbles of carbon dioxide here. What should I do with the bubbles? And with a splinter? I can test the presence of carbon dioxide when the splinter turn off. Why? Because carbon dioxide will does the contrary effect of the splinter. So the splinter is lighter. Then when I try to burn the bubbles of carbon dioxide, I will not, because the carbon dioxide that is found in the bubbles will turn off the splinter. Okay, why do you use carbon dioxide, a solid carbon dioxide freeze, so to turn off fire? In every building we have some what are they, some bubbles filled with carbon dioxide. Okay, so that is, you should remember this. Okay, what about D? What is the name of the salt formed in this reaction?
Calcium chloride.
Exactly, calcium chloride. Okay, let's see the other one. Yes, maybe Ercia, you can read this. Yes.
Teacher Sir Samuel was investigating the reaction below. He placed 4 grams of magnesium ribbon into a beaker of dilute sulfuric acid. He timed how long it took for the magnesium to disappear. It took 45 seconds.
Okay, so here we have sulfuric acid, gas, and magnesium. Yes, tell us which is the reaction. Yes. So magnesium plus sulfuric acid, what will be that?
Magnesium.
So magnesium what?
Sulfate.
Magnesium sulfate, and which is the gas?
And the hydrogen.
Exactly, that's it, right? Okay, what about B? Who is going to do B? Okay, yes.
How would you test for the gas given off in this reaction? Remember to give the result you would get if the test was positive. Adhere to test the presence of hydrogen. We could simply light a splinter, and if we burn the hydrogen, it will make a pop sound.
Exactly. We have done this experiment before, right? Several times in the lab. Okay, can you do the other one as well?
Which of the following would result in the magnesium ribbon disappearing in less than 45 seconds? Warming the acid, using 2 grams of magnesium ribbon, stirring the mixture, adding water to the acid.
Let's talk about each one of them. So what does warming the acid?
Warming the acid, it increases the rate of the reaction, so the magnesium ribbon will disappear in less than 45 seconds.
Okay. We will have more movements, right? More yes. Successful collisions. Yes. What about using 2 grams instead of 4? Okay.
Magnesium ribbon. Using 2 grams of magnesium ribbon would result in again disappearing of magnesium in less than 45 seconds because we are using less solute. So
exactly. So it's it's obvious that will take less.
Stirring the mixture. These two would help to disappear the magnesium ribbon faster than 45 seconds. But adding water to the acid wouldn't, because the acid then would be less concentrated, which would decrease the rate of reaction.
Which will decrease as well the amount of successful collisions, okay? So we will not have the same rate of reaction. Okay, I have a question. Do you see the screen? Do you see 8.2? Do you see this?
Yes.
Okay, thank you. Okay, let's see the other exercise. Okay, if you do not see the screen, maybe someone might have problems. I encourage you to open your course book at page 118 and to see the exercise 8.3, okay? So what says the exercise? Bahula investigates the rate of reaction between magnesium and dilute hydrochloric acid. Diluted acid, marble chips, the gas ring. So why do I need this apparatus for? Okay. Shimmy. Yes, do you have an answer? Someone? So why I am using this gas measuring cylinder? It means that this reaction produces a gas, right? And I am going to collect it, right? So she measures how much gas is given off every 30 seconds, right? With this gas you bring in here. The graph shows her results. So I will have the volume of hydrogen, okay? Hydrogen gas collected and the time taken, okay? Every 30 seconds, she measures the volume of the gas. And this is the graph, okay? So let's see the questions. The first one, how long does it take to collect 30 centimeters cube of the gas? 30. Okay.
Almost 90 seconds.
Almost?
The 90 seconds, if we see the graph.
90, okay. Okay, or 80. It's pretty much. Okay,
like that.
Great. Okay. So, how long does it take for the reaction to finish? Where do I see the when this reaction finished? How can I understand this? which makes me think that the reaction has finished, looking at the graph. Who is going to tell me? 225. Yes, yes, exactly. So here, when we do not have more hydrogen gas produced, I can say that the reaction stopped, okay? Has finished. Okay, so what's the other question, okay? Describe how the rate of reaction changes over the period that the reaction is taking place. So we said that the reaction stopped in 225 around. Then at the beginning, what happens at the very beginning of the reaction? It is a fastest reaction or slowest?
Fastest.
Okay, the very fast. So the fastest part is where? Where in here? Who is going to tell me? Here, so here from around, usually if you can see the rate of the reaction for this gas is quite fast, okay? Until in here slows down and then finished, okay? So usually we have at the very beginning the very fast rate for all the reaction, usually. Okay, predict what would happen on the rate to the rate of the reaction if Bahula increased the temperature of the acid. Okay, we are increasing the temperature. So what will happen?
The rate will be faster.
The rate will be faster, okay?
The rate of the reaction, sorry.
So what do you understand with this? What we have to understand with this? The rate will be faster means that the reaction will stop, will finish faster.
Yeah.
The amount of this product will be in less time taken, okay?
Yes,
Compared
yes.
with the first one. Okay. So what says the other one? Explain your answer using particle theory. Okay, so this is homework. So what we said, we chosen we already answered to the D. We talked about the answer. You are going to explain this answer using particle theory, okay, as a homework. This will be your homework in 2 to 3 sentences.